Alright, so here's the notes about graphing without technology. Okay, so a few things to remind ourselves about, okay, as we get going on this. First is how we find the degree. Okay, remember, use this page for some stuff. Remember, if it's in standard form, like this, and so on, as opposed to factored form, okay, if it's in standard form, we take the highest degree, or highest power, and that's our degree. Okay, if it's in factored form, we add these up. So power of 2, power of 1. So this would have a degree of 3, this one a degree of 5. Okay, so first thing we need to do is know the degree, because the degree is going to help us with the end behavior. So I've got x squared, so there's 2 x's, there's 1x, and then there's 3 x's. So 2 and 1 is 3, plus 3 is going to give us a degree of 6. Okay, now we have to remember how those degrees affect end behavior, right? We have positive and negative coefficients. Okay, so coefficient, right, is like the 3x to the 5th. That 3 would be the coefficient. It's positive as opposed to negative. Okay, we also have even degrees and odd degrees. Okay, so when I look at this degree of 6, I also look ahead here. If it's negative out here, it's going to have a negative coefficient. Okay, so mine's even and positive, so it's going to be this guy. So even and positive, remember, then behavior is both going to positive infinity as we go right, as we go left. If it's negative, they both go down to negative infinity. For odd positive, the right goes up, the left goes down, and odd negative, left up, right down. Okay, so I know with my end behavior, and we had special ways to write it, right? So the limit as x approaches infinity, as x goes to the right, of my function was going up. Up we said was positive infinity, so equals positive infinity. Okay, and then we also have the limit as x approaches negative infinity, as it goes to the left of f of x equals negative infinity. Hopefully you can write a little bit smaller than me so that all fits in that spot. Okay, so having the end behavior, oops, and I did it wrong, didn't I? That's also positive infinity. Okay, so there's our end behavior. That's going to help us as we graph. Now we need to find our zeros and their multiplicity. So remember, for our zeros, we take each of these and set them separately equal to 0. For a lot of them, it's pretty easy to see what we're going to come up with. So for like this one and this one, I know that that's going to be a negative 3. And for the x minus 1, I know that that would be a positive 1. Okay? So I'm going to have a negative 3, 0. Now for my negative 3, there's only one of them, so it has a multiplicity of 1. My 1, however, has 3 of them, so that's a multiplicity of 3. And we'll talk about how that affects what our graph's going to look like. Okay? Now, this other one might be a little trickier, because when it's got that x squared still in there, not around the whole thing, then we want to actually take the time to solve it. So I'd add 16 to both sides. I'd get 16 equals x squared. Take the square root of that, and I get 4 equals x. But you got to remember, it's the positive or the negative version of 4. Because negative 4 squared is positive 16 as well as positive 4. So I have a negative 4. I also have a positive 4, with each with a multiplicity of 1. Okay? By the way, if you're not taking these notes, you should be. So if you need the guest teacher to pause the video so you can catch up, or to back it up because I already erased something, please ask them to do it. And guest teacher, please make sure you do that for them. They're going to be using these notes on Monday to do an assignment in class. Okay? So you guys will definitely want to make those useful. All right. So I then put my zeros on the x-axis because they're x-intercepts. So at negative 4, there's a 0, negative 3, at 1, and positive 4. Okay, so there's my 4 zeros. Now remember, and behavior comes into play now. They're both going to the right as we go to the right and the left, so I know that from this 0 to the furthest right, it's going up. And from the furthest left, it's also going up. Okay, so now the question is, what's happening in between? And that multiplicity helps us with the in-between stuff. Okay, so remember, when we're dealing with multiplicity, okay, we have even and we have odd multiplicity. Okay, even, it's going to bounce or touch. Odd, it's going to cross. Okay, now the lower the odd, the straighter it crosses, right? So like if this is my x-axis, that would be straighter. The higher it gets, the more it kind of flattens out. Okay, whereas with even, same idea. It swoops down and touches. The higher it gets, the flatter it goes when it touches, and so on. Okay, so with our multiplicity, we have 3 of these that are 1. So at negative 3, negative 4, it's going to go through. At negative 3, it's going to go through. At 1, it's going to go through, but it's going to kind of be a little more of a jog like that. And at 4, it goes through. So starting at the left, I'm going to go down, go through, then come back up to hit my other 0, go through, come back down to hit my third 0 and kind of do that little jog, come back down and hit my last 0 and then go back up. So it'll look something like this. Okay. Now for my maximums and minimums, okay, we are going to want to graph these with technology, whether we're using Desmos or our calculators, after we do it by hand. Okay. I know I said without technology, so I want you to graph it by hand without technology, but then I want you to use technology to actually see what those are. Because if we don't know exactly the max and the mins, okay, or the Y-intercept, we know the zeros, we know the end behavior, we can take a stab at increasing and decreasing, but without the maximums and minimums, we can't. We could say positive and negative, because if we have the zeros, we can also get positive and negative, okay? So there's kind of a stab at my practice one. Let's see what it should actually look like. So I'm going to be using Desmos to graph it. You can use the graphing calculators. We've dealt with those graphing, so you should know how to do that as well. You can type it in this factored form just fine. You don't have to change it to standard, okay? Then sometimes I need to play around and see what kind of window I want to make. Sometimes that's tough. So, making that window, notice that I went clear down to negative 400, up to positive 400, but only to the right, positive, and to the left, negative 5. Okay, but we can see that same basic shape of our zeros, right? Negative 4, negative 3, 1, and 4. Okay, crossed quick, had that flattening, then crossed quick again. Okay, now the nice thing with Desmos is it gives us those important points exactly pretty easily. Okay, without Desmos, I would kind of be taking a guess at some of these. Okay, so let me get rid of my end behavior so we can see the rest. So for my Y-intercept, where it crosses, we can see it's at 0.48. Okay. Now the maximums and minimums on our graphing calculator, we can actually find those as well. So I went on the graphing calculator, and here's a screenshot. You can do the same exact thing. Okay, the harder one to get is the Y-intercept for some reason. But we could do a special kind of trace or a table, and you could find that easily. But if when you've graphed it, once you hit, notice I went up to window zoom and went window settings. I went 5 and negative 5, 400 and negative 400 to get my graph a good picture. Okay, we had the basic graph, right? So that was awesome. Then if I hit menu and go to analyze graph, notice I have 0, minimum, and maximum. So again, using that tool, I can find all those pieces of information. Okay? All right, now let's use them. So, Y-intercept we got 0.48. A maximum we have 1 right here, right? So negative 1.77, 336. For minimums we have 2 of them, here and here. So one at negative 3.59, negative 178, and one at 3.36 and negative 394. Okay, so those are all our points. Remember, zeros, y, max, and mins, those are all the points. Now we're dealing with intervals. And with intervals, okay, we only deal with x values. Okay, I think failed to put on here domain and range, but I'll just remind you of those. So domain, remember, is all the possible x values. So this is going to keep going to the left and to the right. So my domain is negative infinity to positive infinity. Now my range, okay, that is how far down we go, how far up. It's going to keep going up. So I know that I'm going up to infinity. But my minimum, okay, was negative 394. So at negative 394, that's as far down as I go. So I go down to up. So there's my domain and range. Now, increasing and decreasing. Here's where we use the maximums and minimums to help us, right? So we start here, clear off to the left, and I'm up at positive infinity, right? And I'm decreasing, decreasing, decreasing till we hit that minimum. So I start at positive infinity, negative infinity, right? Because we're doing our x values. So as I'm going down, I'm clear off to the left at negative infinity. And I go till I hit that negative 3.59. Okay? And so I use the bracket for that. So now I've stopped descending. And now we're increasing up until I hit that maximum. So I start increasing at negative 3.59, then I end my increasing at negative 1.77. Okay, then I start decreasing again, and I decrease clear down to that minimum. So I jump a spot, then I start at negative 1.77, and I'm decreasing until I get to 3.36. And now I'm done decreasing. So then I jump my increasing, and it's just going to keep going up and up, and as we keep going out to infinity. So I start at 3.36 until I get to infinity. Remember, infinity intervals have parentheses, everything else should have brackets. Okay, and notice how the maximums and the minimums helped me with that. Okay, now I use the zeros to help me with positive and negative. Okay. So my start out, as I'm at negative infinity, I'm positive, 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 positive. And actually, I want to do blue for positive, till I hit that 0. So I start out at negative infinity, and I know it's going up, but we're thinking x values, so we're going to the left. We start clear out here at the left at negative infinity, and we're positive till we hit negative 4. Okay. Then I'm going to jump a spot and become negative. So I'm negative from negative 4 until I get to negative 3. Then I jump back up to positive, and I'm positive till I hit that 0 at 1. So from negative 3 to positive 1. Then I'm back to negative, so I'm negative from that 1, so I jump, then from 1 till I get to 4. And then from 4, as I keep going up, I'm always going to stay positive, so from 4 to positive infinity. Okay, so notice, negative infinity to 4, boom, 0. 4 to negative 3, another 0. Negative 3 to 1, 1 to 4, 4 to infinity. So from negative infinity to positive infinity, I'm just kind of jumping around here. Okay, and there are all the things we need to worry about there. Okay. All right, so that's a lot of work. Hopefully you have that all written down. If you need to, have the guest teacher pause the video. Okay, write those notes down. Make sure you're ready to go on that. All right? All righty. Let's take a look at the second problem. See another example here. And I'm actually going to change this to a negative out front there, so we see a negative version. Okay, so that'll change things a bit, but not much. All right, so same idea here. First off, we need to know the degree. So I have 4 x's here, 2 here, 1 here. 4 and 2 is 6, 1 more gives us 7. So it's an odd, okay, and negative. We switched it to a negative. So my end behavior, as I go right, I go down. As I go left, I go up. So the limit, I'll remind you the other way we can do it. As x approaches negative infinity, as it goes to the left, goes up to positive infinity. F of x goes to positive infinity. And as x approaches positive infinity, as it goes to the right, it's going down. F of x goes to negative infinity. Okay. Now we take a look at our zeros. Now these ones should be pretty easy to tell, right? X plus 3 would become negative 3. Okay. And it's got that 4, so we know it has a multiplicity of 4. Okay. Then this one, x minus 2 equals 0. We'd add 2, right? Getting us x equals positive 2. So 2, and it has a multiplicity of 2. And then the last one, x minus 1. Hopefully you saw that you'd add 1, so it'd be x equals positive 1, and it's got a multiplicity of 1. So I do my zeros, negative 3, positive 2, positive 1. Okay. Now I know my end behavior. As I go to the left, I'm going up. So as I go to the left, it's going up. And as I go to the right, it's going down. So it's going to go down like that somehow. Okay. But what's happening in between is depending on that multiplicity, okay? So we have 2 even, so we're going to have 2 touching, one a little bit flatter than the other, and then one that crosses. So I know at 2 that it's going to touch. So it'll touch and bounce back up. Then at 1, it's going to cross, so it'll climb back up and cross, go up, come back down, and then it's going to be a flatter one when we hit it. And so it's going to look something like this. Okay? Now, what I need to do is graph it with technology to see how well it comes, how close we got. So I graphed it with the calculator. I didn't use Desmos this time because I figure most of you guys will probably have just the calculator. So I decided to just graph it with the calculator and went through all the process of finding the minimums, maximums, zeros, all that stuff to begin with, okay? So here's what it looks like, okay? So as we go left, we go up, we come down, we hit that negative 3. See how it flattens out, jumps back up, comes back down, okay? Then crosses at the 1, dives back up, hits, and then keeps going down. So yeah, decent job, didn't we? Let's erase this, and then, obviously you don't have to redraw the graph. You'll just want to then put in the x, y, all that, max, min. Now, in the calculator, like I said, finding the y-intercept can be difficult. So one way that you can do that is we know that the x value is 0. So you could do it by hand by just plugging in 0 into all the x values and then solve to get that. So 0 plus 3 is 3, so I have 3 to the 4th times negative 2 squared times negative 1. Negative 1 and a negative, they'll basically become positive. 3 to the 4th is 81. 2 squared is 4. So 81 times 4 is about 324. So that's my y-intercept. 0, 324. Okay. Desmos helps out with the y-intercept. Our graphing calculators, it's a lot harder. The way I was able to get it to show up is that I went in the menu, went to trace and saw what it was and then put a label there. Okay, so a little bit more difficult. All right, Now maximums and minimums. Now we only have one maximum, so it's right here. So at negative 0.406, comma 369. Okay, minimums, I have two of them. One of them is actually a 0, so negative 3, 0. And the other one is down here, and it's 1.41, negative 54. Okay, so there's those. Domain and range. Okay, domain would be, as it goes left, it's going to keep going up, but it'll keep going left. As it goes down, it'll keep going right. So negative infinity to positive infinity. For the range, in odd ones, you see this, it keeps going up, keeps going down, so negative infinity to positive infinity for both of those. Okay. Then we've got our positive. So we're positive, positive, positive. Technically we're not when we hit the 0, but we'll just pretend it still is. Positive, positive, positive until we hit 1. So we start out, because we're to the far left, we start out at positive at negative infinity until we hit 1. Okay, then we go negative, and technically we're not at 2, but we don't go positive, so we'll just say it's negative and it keeps going. So it's negative from 1 to positive infinity. Because it goes to the right, it'll keep being negative. So that was pretty easy, right? Okay, let's see our increasing and decreasing. So, decreasing, we start at negative infinity and we keep decreasing until we hit negative 3. So negative infinity until we hit negative 3, we're decreasing. Then we're going to start increasing from negative 3 to negative 0.4. So negative 3 to negative 0.406. We are increasing. Then we switch back over to decreasing till we hit our minimum. So we jump and we're decreasing from the negative 0.4 to 1.4. Then we're increasing for a small spot. We jump 1.41 to 2. Then we're decreasing from 2 on. So from 2 to positive infinity, because we keep going to the right. We're going to keep decreasing. Okay? So, there we pretty much go, guys. Keep these notes so that you can do on Monday, do the worksheet. You're going to be doing the same thing. So you're going to graph it by hand first, get the degree, zeros in their multiplicity, and behavior. Do your graph by hand. Then using the calculator, you'll get all that information once you graph it. Okay? So, there we go, guys.